This is section 2.1, power and radical functions. In this section, you should be able to graph and analyze power functions. And in part B, we're going to be able to graph and analyze radical functions and solve radical equations. So a power function is any function of the form f of x is equal to a times x to the n power, where a and n are non-zero constant real numbers. So we need to graph and analyze the function. We're going to describe its domain, range, intercepts, end behavior, continuity, and where the function is increasing and decreasing. So if we graph the function, first it's going to look like this. Then we're going to describe domain, range, intercepts, end behavior, continuity, and increasing and decreasing. So if we start with the domain, if we look at the graph from left to right, they are all values. It is going up very, very quickly, but it would eventually get all the way to the left and all the way to the right. So our range will be negative infinity to positive infinity. On our range, we have 0 and we only have positive values. So it's going from 0 to positive infinity. When we look at intercepts, you can have x-intercepts and y-intercepts. Our x-intercept in this case is x is equal to 0. Our y-intercept is y is equal to 0. If we look at the end behaviors of this function, if you look to the left, the numbers keep getting larger and larger, so it's going up to positive infinity. And on the right side, again, it is going up forever, so it's going up to positive infinity. When we look at the graph, we can see that we can draw it all without picking up our pencil. There are no holes, there are no gaps, there are no jumps, so this is a continuous function. And if we look at the graph from negative infinity until we get to the value of x is equal to 0, our graph is decreasing. And then from when x is 0 all the way to the right, our graph is increasing. If we look at the graph of negative x to the 7th power, it'll look about like this. Again, we're doing the exact same thing. So if we look at our domain, if you look from left to right, there are x values where they do all have corresponding y values. So our domain is going from negative infinity to positive infinity. If you look from bottom to top, we do have all y values. So that will also be negative infinity to positive infinity. Our intercept, again, is going through the origin. So we have an x-intercept of 0 and a y-intercept of 0. If we look at the end behaviors, if you look at the left side of our graph, the graph keeps getting higher and higher, so it's going up to positive infinity. On the right side of our graph, the graph keeps going down, so that is a negative infinity. The graph can be drawn without having to ever pick up your pencil, so we know the graph is continuous. And if we look at the graph, all the way from the left to the right, it is going down, so the entire graph is decreasing, or from negative infinity to positive infinity, it is decreasing. We're going to have to make some scatter plots in this section. On a TI 83 or 84, when you go to make a scatter plot, you're first going to hit the Stat button. You're going to hit Select, and you're going to fill in the information. Your X coordinates go into L1 or List 1. Your Y coordinates go into List 2. Once you get that done, you will hit Stat Plot, which is second Y equals. You're going to turn on Plot 1. We're going to turn it on so it is a scatter plot, so make sure you do select scatter plot. Make sure your X values is your L1, your Y values is your L2. We're going to change our window so it fits the data. One way to do that is to hit the zoom button, and then you're going to select number 9, which is zoom stat. So it'll deal with the statistical value, which is in those lists for you. And we're going to make sure that our Y equals is empty. So make sure you erase out any equation that was in there. And then you can graph. Once we have a scatter plot, we can try to find a power function that will fit the data. To do this, you're going to go to Catalog, which is hit second and then hit the 0 button. We want a power regression. So you're going to, if you hit the Q, that'll take you down to the Q's, and you can go up pretty fast to find the power regression. We're going to hit Enter. And you're going to hit Enter again so it runs the program, and then it's going to write an equation for you from the information. So if we have this set of data points, your M values, both rows of M values, you would put in for your L1. Both of your R rows, you're going to put in for your L2. Make sure you start at the top for both of them and go across. Once you have this done, you are going to create a scatter plot. Then you're going to find the power regression. When you are done with that, you should have an equation that looks like this. Our correlation coefficient, this tells us how well the line actually fits the data, is 0.995. If it's a 1, then that means it fits the data perfectly. So this equation actually does fit our data very well. On part C, it says we need to predict the metabolic rate for a 60 kilogram animal. So that means you're just going to plug in 60 for your X. So if we find F of 60, if you plug that into your equation, you should get a resting rate of 1,554.